Good morning, student. The third problem what we are going to discuss is a problem on truss. Truss is a structural member which is subjected to axial loading. The difference between a truss and the bar is, in case of bar, in most of the cases we assume the bar to be in horizontal direction, where a trusses can be in any direction, any incline to any incline in any direction. There are two different types of 2D truss and 3D truss. The problem what we are seeing in front is a 2D truss member. If the truss member are also in the z direction, then we call it as 3D truss or space truss. So the problem what we are discussing is a 2D truss. Always one should note that there are some assumptions made in while solving the truss problem. Always the loads are applied at the joints. Truss member can be subjected only to the axial loading. Trusses cannot withstand bending, and also trusses are connected through pin joints only. And then these are the few assumptions made while solving the truss problems. So in general, what the student makes mistakes while solving truss problem is they go they will not be aware of the boundary condition. You should see here, this is a pin joint here, and then this is a roller support here. So it is free to move in y direction, and a point load is applied at the node to 1000 newtons. We will go ahead and solve the problem. Preferences. Structural problem is what we are solving. Structural. Okay. Preprocessor, element type, add element, add, link. Okay. Material properties, material models, structural, linear, elastic, isotropic. Young's modulus is given as 200 GPa, 200 E43, Poisson's ratio as 0.3. Say OK. Close. Section. The area of cross section for the three truss elements remains the same. Add. You can give it as 1. Say OK. Area of cross section, it's 50 mm square. 50 should be consistent with the units. 50 mm. Say OK. Modeling. Create nodes in active coordinate system. First node, let it be at the origin. Say apply. Second node is at a distance of 1 meter. Everything should be in mm. 1000. Say apply. Third node, is at a distance of 1 meter. It's 0 and 1000. Say okay. We don't require that root 2. Root a square plus b square. It's root 2. That's it. Okay. Then we'll create the elements through nodes. That doesn't mean that you should create the first element always from first node to second node. You can also select first node to third node, but the trusses constraints what it will indicate finally. The first, if you take this is the first element, then you should see in context to this. So first and second element node. Say apply. Second, first and the third node is mentioned as the second element. Say apply. Third and the second node. Say OK. Now we need to define the boundary conditions. Loads. Define loads. Apply. Structural displacement on nodes. Select this node. Since link element has only 2 degrees of freedom, displacement in x direction and y direction, say OK. It doesn't have any rotational degrees. Sorry, since it's a 3D link element, we may find one more degree of freedom. Translation is that direction. We can consider all degrees of freedom. Say OK. On nodes, select this node. Say OK. It is free to move. It is not free to move in x direction, not free to move in x direction, whereas it can easily translate in y direction. So I left this degree of freedom free. Say OK. And at the force, we need to apply a force of magnitude 1000 Newton at node number 2. Say OK. OK. Magnitude, it's in negative y direction. F of y minus 1000 Newton. Say OK. If you want to see the numbering, you can go to plot controls, numbering, and here the element numbers. Say OK. So element numbers will be this spread 1 2 3, and then solution, solve, current load step, say OK, solution is done. General post processor, it's the same, since these are the 1D elements, link elements, we need to define table, add ls by sequence number, line element stress, ls1, say OK, close. The strains and reaction force remain the same. If you want to define the reaction force, let us see how to define the reaction force. The same thing what we did in the previous two problems. In SMIC1, say OK, reaction force, say OK, close, plot results, line element results, line element stress, say OK. These are the stresses induced. The maximum is in link element 3 of 28.28 MPa. On the same lines you can see the reaction force, reaction, say OK. These are the reaction forces. You can see it in terms of numbers, element solution, x component of stress, okay, it will display blue. These are stresses in x direction, -20, -20, 20. Okay, and then maximum stress is in element 3, 28.28 MPa. Similarly, you can see the reaction forces, all items. Reaction forces -1000 at node 1, and at node 3 is also -1000 Newton. Okay, this is about the first problem. You can also see the 3-dimensional shape, style, size and shape on this. Okay, plot, multi-plots,